All right, so we have ethanol, ethanoic acid. The acid is the carbonyl and the OH. Remember that your OH group, the O is connected to the, or is bonded, not connected, bonded to that carbon. The hydrogen is bonded to that oxygen. And what happens in dehydration synthesis, or recognize that you have an alcohol and you have an acid. When you have an alcohol acid, the OH from the acid and the H from the alcohol group, they are removed in that process called dehydration synthesis. So I'm going to remove those. I'm going to put the arrow there to indicate what one of my products is. One of my products is H2O or RH2O. I could draw it out. It's bent shape. You remember that it had two lone pairs, so it's bent shape. I don't need to. That's not my expectation. I just want you to be aware that you do have two products in this. I'll label the one product that I know, and then I'll move on to the second one. So this is what happens, and I'm going to use my highlighter to explain it. From my alcohol, I'm left with this portion, the two carbon and the oxygen. From my acid, I'm left with the two carbon and my double bonded oxygen as well. So now I'm going to take that blue portion that I had. I'll continue on just to make sure you're clear where everything comes from. And then I'm going to take and connect it to that highlighted purple portion where the acid portion came from. So that's specifically where it connected. It connected, that bond happened right here, where that removal of water, that's where the bond occurs. So that is indicated right here where that bond is. Now we're looking at something called an ester, and we know this because we have this carbonyl group or this double bonded oxygen connected to a single bonded oxygen. And we learned from our lesson last week in the naming, that's an actual ester. So in naming an ester, the base name comes from the double bonded oxygen. So I have ethanoate. And my branch name comes from the single bonded oxygen, which is ethyl. So our name for this is ethyl ethanoate. Ethyl ethanoate. I did mention yesterday the trend that you're going to be seeing in these problems that you did, in these equations that you did. So let's look at, and this one was supposed to be a sweet pair, the second one. The third one that we did one pentanol in our test tube. We had that alcohol, and then we took ethanoic acid again. So my plus sign, acid, and my yield sign. And now I'm going to solve this just using my trend. First of all, recognize that we have an alcohol and an acid. My pen's not working. There we go. An acid and an alcohol. Those two combined produce an ester. Okay, so keep that in mind that you need to specifically have an alcohol and an acid. You're going to always have water as your byproduct. One of your products is always going to be water because that process of dehydration synthesis. And now I'm going to name it without even drawing the actual images just yet. And then we'll work backwards and see that, hey, it is true. So the trend is that from the alcohol is the one that gives the branch name, and the base name comes from the acid. So if that's true, I should have one pentyl ethanoate. One pentyl ethanoate. Again, the trend from the alcohol is that branch name. The base name comes from my my acid. Well, let's draw this out. I have 1, 2, 3, 4, 5. And on the first carbon, I have an OH group. I have a plus sign, and I'm drawing ethanoic again. So it's 2 carbon, double bonded oxygen, and an OH. That's an acid. I'm going to put a yield sign, my arrow. I can draw or just write H2O because I know one of the products is water. I'll indicate that again for you guys. That's how I got my water. The H from the alcohol, the OH from the acid. And then when I put these two together, 1, 2, 3, 4, 5, and then the oxygen stays. And then my double bonded oxygen, my carbonyl group in there. So let's name that. Well, it's ethanoate 2. And then on the first carbon, is my 1-pentyl. So I've named it prior to even drawing it because I do know the trend. And this is not happenstance. This is always going to be that trend. All right, this one was supposed to be smelling like banana. So something like a banana smell. My last one on the lab, the last test tube really was supposed to smell like wintergreen or mint. And I think everyone in this class actually got it. We used a solid salicylic acid. And I drew that out. Let's work on with the trend. I have an alcohol, methanol, and I have salicylic acid. I'm always going to have water, so I'm going to put that down so I don't make a mistake and forget my byproduct. And my branch name comes from alcohol, methanol. So that means my branch name is methyl. My base name comes from my acid. I have salicylic. So if I were to use that trend in our class, we could say salicyloate, just because Mrs. Sulkson has been teaching it. In actuality, just so we're like, I'm teaching you proper also, but this is 100% acceptable for honors chemistry. Salicyloate is not actually the name, it should be salicylate. But again, that's not something you would know to change that. So you can stick with the O8s for everything for an acid. I just circled it. If you want to know the proper name for it, should have been methyl salicylate. Let's draw this and make sure that that's true. Methanol, 1 carbon with an OH group. Then we had a plus sign because it's an equation, and I have my salicylic acid, which is 6, and then I had double bonds everywhere. I had my acid portion, which is double bonded oxygen with an OH. And salicylic acid, the formula actually has an alcohol group attached to the second carbon as well. However, it does not play a role in the dehydration synthesis. So let me outline again. It's from the acid. From the acid, you take away the OH. From the alcohol, you take away the hydrogen. When you remove that hydrogen and OH from the acid, this is where you got, let me get my inking here, you've got water. So let's now make the product of our ester, or our ester. Make my bonds. I'm going to keep the second carbon has that OH, it's not affected. Double bonded oxygen, and then we have the oxygen here. Since we kept with that trend of highlighting, I'm going to just highlight that so we know where it went. There we go. And then I think I made everything else purple for the acid. Made little noises there for you. All right, so you can see where the water comes out and how it's connected. And you don't just take away anything. Make sure that you focus on just that portion. I'm going to stop recording.